Okay. So I'm going to demonstrate a method here with the command line interface that I do not want you to do if you have the PGBook VM. But I want you to be aware of it, and if it isn't explicitly in the study guide at this point, then it will be. I'm going to take my Ubuntu virtual machine and start it. And so if you, as an alternative, had to use a Linux image to set up your own platform for scientific computing applications, if you couldn't import the PGBook VM, then this is something you can do and you should do. The reason you should not do this in PGBook VM is it'll update some things and break some things, and then it won't work when it's time to work. And that's bad. So can everybody see my screen?
Yeah.
Yeah, small dorky screen. I am not using PGBook VM, but I did set up the same password and the same computer name. So I just want you to know, because I'm using a later version of the Linux. So I'm going to type in my password. And you'll recall from our Tuesday class that you can use a single right arrow to take the output of a command and write it to a text file that you name in that command. What does the double right arrow do that's different? Instead of using a single arrow, if I use a double right arrow, how is that different?
Doesn't a double right arrow append or
Yes,
show direction?
yes, good
All right.
answer. So thank you. A double arrow appends the data that you're trying to collect to the end of the existing data in the already existing data file, which is desirable in some occasions. In other cases, you don't want the old data. You want to write it fresh every time. So if you want to write it fresh every time to a file, you want to use a single right arrow. That's called the redirect. And then you want to use the append operator, the double right arrow, to add it to the end for every case that you want to grow a file and keep growing it and keep growing it every time you run a command. And that's important. So we're going to have all of these different apps, and eventually we're going to want to stitch them all together and have a few commands that kind of do all the magic automatically. One of the things I want to do here, I better check to make sure I'm on the internet just to be sure. So at home, if you haven't already, you may want to go ahead and you may need to connect your system, depending on the network card settings. You have to look for a wireless adapter or a wireless connection, and then you have to put in the SSID or the password for your wireless to connect your virtual machine. If I didn't do that on this one already, oh, I did. Okay. So now I have active internet, and so I'm going to use two commands with the double ampersand operator. I'm just going to close my browser, and so this command is going to require root privileges. And there's two ways to do root commands or root privileges. You can issue every single command with sudo and then the command. And then it's going to prompt you for your password every time the command runs. That's a best practice. Now, if you know what you're doing and you've been around a while with this stuff, and you're not going to browse the web and do email through an elevated terminal prompt, then you can do this. Sudo, I want to do super user. It's going to ask me for the password, and now it's going to change the prompt to root. Whoops, hold on. There we go. I'm going to clear the screen because that's just embarrassing. No, that's embarrassing too. CLS and DOS, it's clear. In Linux, it clears your screen. Okay, so this shows my home path. I'm in home PG book, right? And this is the user that's logged in, right? Oh, didn't clear, it just pushed it off the page. All right, so now every command I make, I don't have to have super user credentials because I'm, by default, that's the nature of this prompt. And that's going to be important for some of the things you try to do with scientific computing applications. I'm going to do an apt-get. So if I want to run updates, I installed this, it's version 16. The Linux Ubuntu version that's out now is 20, so I want to update it because I want stuff to work right. I'm going to demonstrate how these two commands can work together. So one of the commands is apt-get, and then you're going to say update. So I want to update the catalog of available updates. I know that sounds funny, but let's state that again. I'm going to update the catalog of available updates and fixes and patches and new versions. But then I'm going to chain the command. Now I'm not really chaining it. I'm going to sequence the command before I do the next one. And that's upgrade. So I have two commands. And the thing that I want you to appreciate is that with the redirect, the right redirect, and the double right arrow, the append operator, and with pipe, the pipe operator, we're taking the output of a command and feeding it into the next one. And sometimes you want to do that. You want to take the output of one command and feed it into the next command. So you, depending on the circumstances, you'd use the single right arrow, the double right arrow, or the pipe command. But there are times when you want to do just one command and then the next command and then the next command because you want to get a cup of coffee and you don't want to have to keep entering commands. So you're going to do a double ampersand. And what's going to happen is that you're going to see the first half of this execute, and then this part of it's going to end. It's not going to take the output and do anything with it. It's just going to run. And then this next application is going to execute. And because this one was successful, that one will work. They're related commands, but if you don't update the catalog, you'll go to upgrade and it'll go, you can't upgrade anything. You're like, dude, I know. This is version 16. They're on version 20. I'm quite sure there are upgrades out there, and my scientific computing application isn't working, and the database that I have for the dolphin data, what am I supposed to do with the Marine Center, right? How's that supposed to work now? I don't want you to stress. I want you to remember these things. So now the first command is running, and it's going to finish running after a point. And depending on the speed of your internet connection, how much data you're pushing up and downstream, and while we're recording a live video session, yeah, there might be some lags. So it's often good to work with a virtual machine that's sitting on a high-speed line instead of having one that's running on your machine if you're there. Now, you're going to get some stuff that says could not lock the var, whatever, blah, blah, blah. That has to do with the disk drive. You don't have to worry about that. We're not worried about that. But basically, well, I guess maybe we do have to worry about that. If that derails the rest of the command from running, I think we have to fix that. So let's talk about how to fix that. If you get a command like this, you go to devices, you go to optical drives, and then, well, this is grayed out. It says remove disk from virtual drive. So, Oh, I know what E drive is. E drive is the shared folder that we set up so we could copy stuff between the Linux and the Windows machine, or the Linux and the Mac machine. That's what that's about. Let's hit this again and see what happens. Or let's do this. I'm gonna hit my up arrow key. I'm gonna use my left arrow. I just want to run the second command and see if I get the same result. I want to see which command generated the could not get lock. Yeah, that one. Okay. So that's something we need to resolve. All right. I'm not going to get hung up on that right now. The purpose of this demonstration was to show you how you can chain commands together that don't have anything to do with each other. Just they'll execute in sequence, first and then second and then third and so on. And that's a very useful technique in the terminal with Linux commands, or also in the command prompt on a Windows machine. And of course, yeah, there are GUIs that pop up and it says, hey, do you want to do 18? And then when I load 18, it's going to say, hey, 20 is available. No, I don't. I don't want to upgrade. I just want to update the stuff that I have on 14 because, or 18, it's supposed to be long-term support. It's supposed to be able to run with this version. Any questions so far?
Not at the moment.
I said there was an unusual command that you would use if you were working a command and you had the wrong option selected and you were getting an error about the option. What command would you use next to get the information you need to execute the correct command to get on with business? And let me tell you, the assessment scenario is not going to be that simple, and I'm not going to state it quite that way. I'm going to show you a screen. I'm going to show how it didn't work right, like we did on Tuesday. I'm going to say, what command should you run next to move forward with a correct, to correctly run your application? If there's an option that has what in it? Anyone? Crickets?
Yeah, crickets.
Does this help? So I suppose I have a problem somewhere with the apt-get upgrade command. So I have an error.
Try to do it manually.
Well, no, all right. So I'm glad this came up. I'm so glad somebody said that. I am so glad somebody said that. And I want to thank whoever it was that said that. Man doesn't mean manually run it. Man means get the manual for that command so you can see if there was a option that you didn't use right. And so it tells you all of these different details, right? And instead of using man, okay, you can get quick help by using -H. That's nice to know, or --help. That's good. So some Linux utilities have those built in. Some Linux utilities don't. If you want the full book from the people who created it, use man. Update tells you, oh, we're resynchronizing the package index files from their sources. So we're going out on the, what does that mean? I'm going out on the internet, I'm finding out, okay, which software is at what version? Oh, I have out-of-dated software. And that's what it means. So it's updating the catalog or index files. And then we're doing the upgrade command with apt-get. It says we're going to upgrade. And then distro upgrade, there's all these different options, right? Install, so apt-get install is followed by one or more packages. So if you get out on the internet, hey, I want to load this, apt-get space install space Python. And see, let's talk about this. I'm going to quit out of here because when I hit Q to quit. Because when I start man, it's going to open up like a little terminal window within a terminal window, and I want to get back to my prompt, so I have to hit Q. I want to install Python, because if I do this, and I want Python, in the PG book VM, if I hit Python and I hit enter, I get this. and then I can go away with Python. Not every Linux distribution has the software that you need. We're going to use some SQL applications to work with data. If you're building your own pgbook VM out of necessity, you may have to install something. So you're going to use apt-get install SQLite. Okay. So if I issue a Python command right now, it'll work, only because that's already loaded. But, oh yeah, so I'm going to use Control D to exit out of there. So let's try SQLite. No, doesn't have it. I don't know where it is. Let's try to run an HTTP. I want to see if there's a web server running on this, because a lot of Linux distributions come with their built-in web server, and you can actually create a website and then run it on your own virtual machine, and then people can browse your website, which is kind of cool. It says no, this program is currently not installed, but you can install it by, oh, look at that. Apt, and I would say apt-get install HTTP-IE. So it's telling you what you need to run the program. That's helpful. So then you would run apt-get install HTTP-IE, and it'll set up a web server on your. So just understand, this is how we work within Linux. Not so much GUI. You can do this. And let me see if we can do the same technique we did in Windows here. So I'm going to list my files. I have a couple of directories, and then I have everything in blue is a directory. Everything that's not, that's in white, is a file. And let's get a little more detail now. I'm going to do ls dash, HAL is actually much better, but I don't want to overwhelm everybody, so I'm just going to use a dash L. Okay, every time you see a D, that's a D. Now, this is a great way to introduce permissions. Examples.desktop. That's in this folder. It's a file. It's a file because we don't have a D in front of it. So if the ls-l listing has something with a dash, that means it's a data file. It's not a directory. If it starts with a D, then it's a directory. You've seen something about this in your textbook by now, right? Maybe? Yes? No?
Yeah.
Yes.
Okay. Did they explain the permission stuff?
No, I don't recall getting too deep into the permissions.
Okay. So in every listing, there are 3 security principles, or 3 security interests.
Read, write, execute.
Well, those are the settings. When they're turned on, they'll show up as R, W, and X. And that's this first 3 settings. After the initial character, the first 3 settings are the owner settings. One difference between Windows and Linux that's annoying is that everything in Linux is turned off intentionally. If you don't turn it on, it doesn't work, and you have to explicitly turn it on, which is why Linux is generally a much more secure operating system than Windows or Macs. Here's the thing. This file, not this directory, this file has read, write, but not execute, because the X is a dash, okay? So that's the first cluster of permissions. The first 3 belong to the owner, or the person that created it. On Tuesday, we created it, or some time ago it was created on September 15th. In any case, read, write, but not execute. The next 3 have to do with the group permissions. So you can designate a group account or a security group in Linux, and you can give them, you can turn on read or write or execute. And then finally, here's the part that I find that makes me shudder. Everybody's like, oh, Linux is so much more secure. No, it isn't. Because believe it or not, there are some people that use the command to change permissions, and they turn all three of these up so it goes RWX, read, write, execute. Those last three are for everyone. I'm not talking about everyone else on the machine. I'm not talking about guests or users on the machine. I'm talking about literally everyone on the planet. This is generally not, if you want to have any kind of security for your data, you generally don't want to leave any of these lit. You want to see dash, dash, dash. And I might just throw that in as a bonus question on your assessment for Module 2, because I want you to understand a little bit more about this, and I'm going to have to add some more details to the revision, the final revision of the study guide. So we're going to revise the study guide. It's going to have the student learning objectives. We're going to map the headers of each section out to the, we're going to do that, right? That's going to happen. Any questions at this point?
None from me.
Okay. So a lot of times, if something isn't running, it hasn't been installed. That's why we covered the install commands. And we went through the steps to update the catalog first with update. And then we use what to install? Well, to upgrade or to to load all the fixes and service packs. For existing software, you use upgrade, but only after update is used. And then what do you do to install? apt-get or apt apt install, and then the name of the thing, right? So if it's SQLite, it might give you a prompt and say, oh, no, you want SQLite IE. If we had issued that command, we would end up loading it on here. Any questions before, all right, so that's the first piece. If it isn't running, if it isn't working, it's because it wasn't installed or set up. If it isn't running or working other than that, it's because the permissions, it's not in the directory itself, so you have to change directories. And the third scenario is if it's not running or working, the permissions aren't set right. So what am I saying? The stuff could be installed. Yep. And everything could be updated. And the stuff you want to run is in the directory. You look inside, you do an ls, and you're like, this thing is sitting right here. Why doesn't it run? It's not running because of this. It's not turned on by default. Execute privileges are not turned up for a lot of things unless you specifically issue the command. Chmod is the name of the command. Change or modify security, right? Chmod. And gosh, how do you use Chmod? Well, that's another fascinating topic all by itself. And it's kind of very irritating, but there's an easy way to do it and a hard way to do it. And I would suggest that you YouTube it, or I'll put a YouTube link out of there that makes quick work out of it. But you're basically using numbers. So if you use a 7, Chmod this, right? Chmod 755, what you're doing is you're saying 7 turns on the read, the write, and the execute. 6 only turns on the read and the execute. 5 turns on the read and the write only, but not the execute. So there's this little table, and you have to know, and you're using 3 numbers. The first number is to set the owner permissions. The second number is to set the group permissions. The third number is to set the everyone permissions. I'm going to say this. You heard me say dash, dash, dash is what you want. This needs to be dash, dash, dash if I don't want just anyone in the world to get a hold of it when they connect to my machine. So I need to take this out. So I'm gonna do something weird. I'm gonna go ahead and say I'll change this so it's read, write, execute, and then I'll change it so it's read, write, and I'll change this so that it's nothing. So I'm going to do chmod, and well, so first I'm going to do chmod -h because I want to know, do the numbers come first or does the file name come first? I forget. Okay, I'm going to do chmod -help because sometimes they build in the -h, sometimes they don't. Okay, so change mod option and then the file name. See that? Change mod, then the option, then the file name. So now you can use pluses and minuses, and that gets kind of interesting, but you probably want to read up on that, how to do that a little bit, because you don't want to just copy and paste stuff. You can see a lot of useful YouTube videos, and they're created by hackers, and they go, oh, if you use Linux at home, I want you to do this, and this will help you. It'll be so much easier than you do this kind of stuff, and you've just opened your machine up to everybody. So I'm going to go ahead and list my files again. And this is what I have. And what I want it to change to is -rwx, read, write, execute. I want the owner. I'm the owner. I want to execute it. I also want my group to be able to read and write to it. Or let's just say read and execute. I'll change that to read and execute. Notice how most of these are read and execute. Not read and write, but read and execute. So this would be the Windows equivalent of modify. This would be the Windows equivalent of read and execute. So yeah, I'll go ahead and do that first. I'm going to go ahead and issue the command for this file so that as the owner, I can do anything I need to it. Because I'm trying to do this assignment for Professor Kentop, and this is driving me nuts. And oh, man, I got a month left of this semester. Yeah, that's why I'm demonstrating this for you. Okay. I'm going to put 750 and then examples.desktop. Now this is the other irritating part about Linux. How do you know the command worked? In Windows, if you do something, it'll say, oh, your changes are complete. And you click OK. Or on a Mac, it says, oh, you finished installing it. You say, OK. What does Linux do?
Nothing.
It just blinks. If you get the command prompt back, if you get the pound prompt back, it worked. If it sits there and blinks over here and you never get this back, it didn't work. Something hung. And sometimes you got to wait a long time for a command to run. But what I want to do now is repeat the list command, and I'm going to hit my up arrow twice, because that's a cool little Linux thing where you just keep hitting your arrows up or down, and then you just reuse your commands, so you go faster and faster and faster the better you get at it. And now, looky. Okay, I just made this private. Meaning, even if somebody connects to my Linux machine while I'm on the internet, the everyone option is shut off. No one can read. No one can write. No one can execute. That's what I want. There will be a question about that on your assessment on the midterm next week, later next week, and then on your final at the end of the semester. Everybody needs to see this. I'll show you a picture and I'll say, somebody from a remote campus is trying to run your stuff and they're connected to your system and they can't do it. And I'll show you this picture and I'll say why. You go, oh, because everyone is turned off, off, and off. That's why they can't. And that's as it should be. Any questions before we clear this? Just remember, your stuff isn't working. Check update, upgrade, install. If you don't even have the software, install. If that doesn't work, make sure it's in the directory in the path where you need to execute it. Move to that directory where it is and try to run it from there. If that doesn't work, you're changing the permissions. That's it. It's like a waltz. If you do those 1, 2, 3, 1, 2, 3, 1, 2, 3, Linux starts to melt away. It's not difficult at all. And then sooner or later, it's like it's intuitive because you're hitting the arrow keys and you're flipping right along. Okay. I'm going to go ahead and minimize this then. And what I'd like to do is show you something that you may have seen before, and I need you to tell me if you have. No. Nope. Module 3. Where is it? Oh, there it is. It was there all along. Sorry. Okay, so I'm going to have you do something just to do some light organization. And so I'm going to ask you to start working with data elements. And I want to call this out for you here. So there's a process that you go through to set all this up, and there's a video, a YouTube, but in a nutshell, in the time remaining that we have for class, is everybody familiar? Have we talked about kinetic energy and 1/2 mv squared and all that?
I know a bit about stuff like that because I did physics, but I don't think we talked about it in this class.
Yeah, we have not talked about it in this class.
Okay, well that's great because we're going to talk about it here. And no, I'm not going to expect you to know physics. I will say that that you can do some modeling, and so part of this scientific computing applications thing is to dabble with this idea of modeling. And one of the things that kills young people, young adults, the second highest cause of, or third highest cause of mortality among people your age, it's car wrecks. So when people are going twice as fast, they think, oh, the energy of impact that's absorbed by the bumper and the people who are in the crash, it's twice as bad. No, it's 4 times as bad. If you're going 20 miles an hour and then you hit something going 60 miles an hour, that's 3 times as fast. Everybody thinks, oh, that's 3 times the amount of damage and pain. No, it's 9 times. It's 3 squared. It's a squared function. Kinetic energy changes proportionally with mass. So if you increase the mass by 50%, by 100%, then the kinetic energy of something that's moving, the energy that an object possesses because it's in motion when it hits something, and then there's transfers issues, and then we get into engineering discussions. We're not going to go there. We're just going to keep it simple. We want to be able to measure the energy of an object because if it impacts something, it's going to release that energy. Everybody with me so far?
Yeah.
Yeah, that's not the same as potential energy. We're not going to go there, but we're going to talk about the energy of motion, kinetic energy. Kinetic means motion. So if we increase the size of the object, the increase in kinetic energy is proportional. So if I double it, the kinetic energy doubles. If I quadruple it, it doubles. That's how that works. So if I'm in a car that's twice as big and I hit something that's twice as small, well, that's a factor. Yeah, everybody gets that. But then they apply the same logic to the speed, and that's a no-no. And what I want you to understand is that the same works for hurricanes. Oh, the speed of this hurricane is only 80 miles an hour. Oh, the speed of this hurricane is 160. It doesn't have twice the damage. It has 4 times the damage. Now that's a painful thing to say, and we all know about that. But the point is that we want to see what happens to kinetic energy as mass increases. We want to be able to measure that, and then we want to flip it and be able to see what happens to kinetic energy as velocity increases, and then we want to compare the two side by side. Look at this curve and look at that curve. More importantly, in some experimental scenarios, we want to create a model like this, and then we want to conduct experiments, and then we want to read where we are when we measure. We're going to say, oh, yeah, well, what was the kinetic energy of that bad boy when he hit? Oh, it was 30,000. So you're going to read 30,000 across. You're going to go, oh, this was its velocity. And so what you want to do is you want to check and use mathematical, scientific relationships and equations to your advantage. You want to create a scenario, and then you want to do some trials to see how your results are tracking with those trials. Now, why wouldn't you just dive in and start using the things? Because your experimental methods might be different, because the materials you're working with might be different, because you're using Play-Doh and it sticks when it collides, as opposed to rubber when it bounces, and that's impact or impulse, and then you have a different scenario. And so there's a different formula that applies for that. So the point is you want to be able to try things out, and you want to see them. Half of this, though, the equation or relationship is specific. 1/2 m v squared. That's a coefficient. 1/2 is 0.5, and I have to use it in every one of these formulas. So basically, what I can do is I can change. All right, so this is going to see what happens when I increase velocity, right? I'm sorry, here's the velocity. But the mass is constant. So I'm not changing the mass. In this screen, right? So I'm noodling. I want to understand this relationship. And this is highly encouraged. Before you start actual experiments with real materials, that's expensive, you want to do some of this first. So you're going to increase the mass. Oh, give me that weight over there. It's twice as much, right? So what I did here was I created a formula on the spreadsheet to automatically increase by 1.25, a factor of 1.25. In layman's terms, 25% increase with each click down the column. So the mass increase is 25%. And if I do the math and grab my handy calculator, 6.3 is indeed 25% more than 5, and so on, and so on, and so on, and so on, down the chain. Now, the cool part is with spreadsheets, I can automate the calculations, and we want to be able to do that. I can use a formula that says, okay, I have an initial value of 5. Now I have this value, d5, which is this constant that I started with, 5. And I'm going to multiply it by this increase factor, okay? That's what the B9 is. Except you'll notice here the dollar signs. So what am I saying? Normally in a spreadsheet, I'm just going to escape out of this because I don't want this to be messed up. All right, so normally in a spreadsheet, if we have things that are constants, we want to put them in the upper corner of the spreadsheet or to the left side of the spreadsheet, and we want to label them. And then as we use them in formulas, what we're going to do is we're going to refer to them, but instead of having a plain column letter row number designation like this right here, I put the constant 0.5 into cell B5, and cell B5 is a variable, or well, it's a cell and it acts like a variable. I can store this, I can change it, I can make it 1, and then all hell breaks loose. Let's do that. Oh, the whole thing changed. That's because I have all these formulas rigged a certain way. I'm going to show you how to do that so you don't have to keep rekeying things over and over again. It's really sweet when you learn that technique. They're like, how'd you do that so fast? Oh, it's really easy. All right, so here we go. We have the constant. I put in 0.5 again. This cell is referred to by its column and row. You may know that already, B5, yeah? So when I want to use this, I'm going to refer to B5. So in the calculation, you see I'm referring to B5, but there's a dollar sign there. Why? Because I copied and pasted that same formula down the column. to reuse it over and over again. And as I go down the column, it's going to want to take C5 and D5 and E5 and F5. It's going to be relative. It's a relative cell reference unless I use the $sign in front of the row and a $sign in front of the column. See, otherwise, look, watch what happens here. This is D6 or D5. When I come down here, I'm going to take this value, multiply it by 1.25, and I'm going to store the result in here. So I'm going to create a formula equals D5 times B9. That's what's in here. Equals, oh, wait a second, what did I do? This is D5. This is, okay, there's my formula. I was noodling around and clicking on other cells and then I lost my bearing. All right, everybody look at the formula up here. All right, if I click into here, I want this result to take the contents of D5 and multiply it by the contents of B9. But as I move down, I don't want that B9 to become B10, B11, B12, B13, because that 1.25 factor of increase is only listed in B9. Does that make sense? If it becomes B10, if I copy this formula down the column, what happens is that it's going to look here next, then there next. Oh, there's text in there. I'm going to get an error. Oh, there's text in there again. Another error. Oh, now it's 20. As I keep going down the column, the equation's going to repeat, but it's going to repeat down the column just as I'm moving down the column with it, unless I use an absolute cell reference or an anchor. So instead of having just the letter and the number, look at those two differences. D5 is a relative cell reference in the formula. B9 is an absolute reference. It's anchored. So when I do this, now what do I mean by I'm going to do this? Let's pretend that I ruin this. I'm going to ruin this whole thing. I'm going to delete all those mass entries. Oh, I just destroyed my chart. Oh, I can't see how mass changes or how kinetic energy changes as mass changes. I've just ruined everything. Well, I'm going to take this and type in equals this, and then I'm going to use the asterisk times this. Oh yeah, all right, so part of it's back. That's good. Everybody with me? Except now, I got to do it again. Equals this one above it. So each time I come down, I go 25% more, 25% more, 20. I'm going to increase from 6.3 by 25%. I'm going to do this times this again, right? And if I try to paste it down, I'm going to highlight this down there because I want to finish it. I'm going to fill it down. Oh yeah, I'm going to use a fill down option, which is cool in spreadsheets. It means you're copying the formula down there, and that's what we want to do. You want to use the tools that are there. I'm going to Alt-E for edit. I'm going to use an I for insert, and then I'm going to use a D for down. Oh, why do I get errors? Well, that's because if I look at what's in here, the values up here keep changing as I keep going down, and I'm not pointing to this, and I'm not pointing to the one right above it. So what am I saying? I'm going to delete this again, and I'm going to do it a little different this time. I'll do the first one. Equals this times this. Yep, that's the right answer. But I want to fill this down, and this next cell, the one that's repeated, it's not going to look to the 5, it's going to look to the 6.3. I'm not going to continue to look at the 5. So that's not this column value is relative. It's going to shift with it. This one isn't. I'm using B and 9. So I have ranges of changing data in one part of the spreadsheet. I have constants to the upper left corner and to the bottom, and that allows me to automate a lot of the process. Does that make sense? Now, if I don't change this before I paste down, it doesn't work. But if instead I say, okay, that's B9, let's anchor it. I'm going to put a $sign. and then a dollar sign. I'm anchoring the row and I'm anchoring the column. I can anchor just the column or just the row, but I want to do both. Now I have the same answer. Why? Because all I did was change the type of cellular reference, the cell reference. This one's relative, that one's not. This one's absolute. Now I'm going to do this down. Alt-E for edit, I for insert, D to fill down. Whew. Oh, so nice. And what happens if I want to see what happens if it increases, if mass increases 50% instead of 25%? Oh, I'm going to do a factor of 1.5. Boom. Oh yeah, see that increased 50% every time, and the kinetic energy changed. Look what it did on the graph. I didn't have to keep re-editing, keep re-editing, keep re-editing. Did everybody get what I'm doing here?
Yeah, you get it.
Okay. So you got to play with this a little bit, but we're going to go ahead. Now we're getting short on time, and I know we're on a 1 o'clock boundary, and you may have other classes. So we will. I'm going to put some quick reference information out over the weekend. On Tuesday, I'm going to show you what you need to do for both the solution, and we'll have the final version of the study guide so that you'll know what to expect on the assessment. This is one thing you're going to do for Module 2. You're going to build this spreadsheet because I want you to be able to follow the process along for organizing data, arranging data with a sensibility that allows you to vary in one sense and keep constant in another. Okay? Everybody with me? We're going to do the mass and we're going to do the velocity. In this case, the mass is constant, not the velocity. See, here's velocity constant. In this case, the mass is constant, but the velocity changes. All right. Any questions about data arrangement, organization, placement that allow for sensibilities with repeating formulas and all that? You there? It's okay. I'm going to go ahead and stop the share and stop the recording, and I'll post this, and then we'll do some more on Tuesday. But I'll also post some references about how to do this assignment, and hope you have a good weekend.
So wait, okay.
Okay. Hey, Professor Kintop,
Yes.
are you there?
Yes.
So on my computer from the library,